Hello, I'm Larry Ballou. I'm a solutions architect and lead the training and consulting services for automotive cybersecurity at SAC. I hope that you enjoy this presentation I put together on automotive cybersecurity and the UNECE WP.29 regulations 155 and 156, which were both approved as of March 4th, 2021. These have a lot of similarities, so I thought I would cover them together and kill two birds with one stone. Note that throughout this presentation, I've used a forward slash, such as that between 155 and 156 here, to call out the differences between R155 and R156. In this 1-hour session, we'll dive into the regulations 155 and 156, which addresses developing and maintaining a cybersecurity management system, or CSMS, and software update management system, or SUMS, respectively, throughout the entire life cycle of vehicles. Enjoy. During this session, we'll cover an overview of UNECE WP.29, both in general, as well as its applicability to R155 and 156. The overall structure of these regulations, which between both are similar enough that it led me to combining them here. Details of Annexes 1 through 4 for both, again, very similar. And near the end, I will break out Annex 5, which is specific to R155, as well as the details of Section 7, for which, as you can imagine, each has very different specifications. In this section, I will go over UNECE WP.29, which is the United Nations Economic Commission for Europe, Working Party 29. WP.29 is also referred to as the World Forum for Harmonization of Vehicle Regulations. Well, we all desire to be working in harmony, right? The United Nations Economic Commission for Europe, UNECE, is one of the 5 regional commissions under the jurisdiction of the United Nations Economic and Social Council. It was established in order to promote economic cooperation and integration amongst its member states. The Commission is composed of 56 member states, most of which are based in Europe, as well as a few outside of Europe. Although I've seen the number 56 exaggerated to 58 and 64, so don't get too hung up over that. WP.29 is a working party of the Inland Transportation Committee, or ITC, of the United Nations Economic Commission for Europe. WP.29 was established in June 1952 as the working party of experts on technical requirements for vehicles, while its current name was adopted in 2000. 3 UN agreements adopted in 1958, 1997, and 1998 provide the legal framework allowing contracting parties, member countries attending the WP.29 sessions to establish regulatory instruments concerning motor vehicles and motor vehicle equipment. UN regulations annexed to the 1958 agreement, they generally have a prefix E/ECE/trans/505/ ... UN rules annexed into the 1997 agreement, and UN Global Technical Regulations, GTRs, associated with the 1998 agreement. The forum works on regulations covering vehicle safety, environmental protection, energy efficiency, and theft resistance. This work affects de facto vehicle design and facilitates international trade. The forum has active participation of countries in all continents, excluding North America and China, who developed incompatible standards. Whereas North America practices self-certification, so rather than a UN-style system of type approvals, the US and Canadian auto safety regulations operate on the principle of self-certification, wherein the manufacturer or importer of a vehicle or item of motor vehicle equipment certifies, i.e. asserts and promises that the vehicle equipment complies with all applicable US federal or Canadian motor vehicle safety, bumper, and anti-theft standards. Within the WP.29 organization, there are 6 permanent working parties, which are subsidiary bodies that consider specialized tasks consisting of people with a specific expertise. such as noise and tires, GRBP, light and light signaling, GRE, pollution and energy, GRPE, automated and connected vehicles, GRVA, general safety provisions, GRSC, and passive safety, GRSP. The automated and connected vehicles, or GRVA, is the working party that we in automotive cybersecurity world are most concerned with. I will be addressing R155 and R156 here, but we'll leave R157 for another day. UN regulations contain provisions for vehicles, their systems, parts, and equipment related to safety and environmental aspects. They include performance-oriented test requirements as well as administrative procedures. The latter addresses the type approval of vehicle systems, parts, and equipment, the conformity of production, i.e. the means to prove the ability for manufacturers to produce series of products that exactly match the type approval specifications, and the mutual recognition of the type approvals granted by contracting parties. Of course, regulations number 155 and 156 are what we in the automotive cybersecurity world are most concerned with. First, let's be clear. ISO SAE 21434 documents the work products to comply with R155, and ISO 24089 documents the work products to comply with R156. Also, the overall structure of these regulations is so similar it led me to combining them here. Remember, CSMS and SUMS are the acronyms for Cybersecurity Management System and Software Update Management System for R155 and R156 respectively. A CSMS covers all life cycle phases of vehicles from development through decommissioning. Processes include vehicle risk management, security testing, field monitoring, and incident management. Whereas SUMS covers safe and secure update mechanisms, documentation on impact assessments of software updates, as well as the management of software identification scheme, or RxS-WIN. A certificate of compliance, or COC, is valid for a maximum of 3 years and is reissued or extended after the end of the period of validity. It is specific for different vehicle types. It is the same process for both R155 and R156. Finally, regarding application of vehicle types, you shall employ CSMS processes during the development and production to ensure cybersecurity, conduct vehicle risk assessment, and implement security measures. Additionally, you shall employ SUMS processes to provide perfection of the RxS-WIN numbers, safe and secure execution of over-the-air updates, as well as testing the effectiveness of implementing security measures. In this section, I'll go over the structure of regulations 155 and 156. Here, I've listed the 12 sections. In a few, I will also list the annexes. Notably, there is not a bibliography. Rather, references are in the footnotes for some pages. Finally, Section 7, Specifications, is where R155 and R156 have very specific verbiage. So I broke the details of those sections out separately at the end. Perhaps you know that ISO SAE 21434 had a table representing the clauses and subclauses. Well, neither R155 or R156, or even ISO 24089 for that matter, documents did. So I've taken the liberty to create one here. As you can see, it has 12 sections, as just mentioned previously. I suppose you could also refer to them as clauses, as with ISO SAE 21434 and ISO 24089. And again, each section has multiple paragraphs, again, which I suppose you can call subclauses too. But do yourself a favor and don't get hung up over semantics, my friend. As we cover each section, I will point out the similarities and differences in more detail. At a high level now, note the following. Sections 1 and 2, scope and definitions for R155 is a bit longer. Section 3, application for approval, are the same, except R156 has a section 3.6. As such, the numbers are slightly different. Section 4, markings are identical. Section 5, approval, well, for R155 is a lot more verbose. Section 6, Certificate of Compliance, are similar, but of course R155 lists for CSMS and R156 lists for sums. Section 7, Specifications, are understandably different, and R156 actually calls it General Specifications. Section 8, Modification and Extension of the Vehicle Type, is slightly different. Section 9, Conformity of Production, is slightly different. Section 10, penalties for nonconformity of production, they're identical. Section 11, production definitely discontinued, are identical. Section 12, names and addresses of technical services responsible, well, those are identical too. Similar to how I did with the regulation sections, I will point out the annexes' minor and major differences relative to R155 and R156. For Annex 1, information document, paragraphs 1 through 8 are the same for both, whereas paragraph 9 is specific to each. For Annex 2, communication, these are basically the same for both. For Annex 3, arrangement of approval mark, well, those are identical for both. Annex 4, model of certificate of compliance, are identical except mentioning CSMS versus sums. Finally, R156 ends after Annex 4, whereas R155 has Annex 5, a list of threats and corresponding mitigations. Now, let's first discuss sections 1 through 6. First, I will cover R155 scope. Note that R155 also includes 1.2 through 1.4. Following, I will cover what each vehicle category is. Paragraph 1.1 states that this regulation applies to vehicles with regard to cybersecurity of categories M and N. This regulation also applies to vehicles of category O if fitted with at least one electronic control unit, or ECU. Paragraph 1.2 states that this regulation also applies to vehicles of categories L6 and L7 if equipped with automated driving functionalities from level 3 onwards, as defined in the reference document with definitions of automated driving under WP.29 and the general principles for developing a UN regulation on automated vehicles, or ECE/Trans/WP.29/1140. Paragraph 1.3 states that this regulation is without prejudice to other UN regulations, regional or national legislations governing the access by authorized parties to the vehicle, its data, functions, and resources, and conditions of such access. It is also without prejudice to the application of national and regional legislation on privacy and the protection of natural persons with regard to the processing of their personal data. Paragraph 1.4 states that this regulation is without prejudice to other UN regulations, national or regional legislation governing the development, installation, and system integration of replacement parts and components, physical and digital, with regard to cybersecurity. Finally, R156, paragraph 1.1 states that this regulation applies to vehicles of categories M, N, O, R, S, and T that permit software updates. Speaking of vehicle categories, as defined in the Consolidated Resolution on the Construction of Vehicles, both R155 and R156 address vehicles of categories L, M, N, and O. L addresses motor vehicles with less than 4 wheels, motorcycles, which will be required to comply with R155 as of July 2029. M addresses vehicles having at least 4 wheels and used for the carriage of passengers. For example, a standard car with 2, 3, or 4 doors, but also buses. N addresses power-driven vehicles having at least 4 wheels and used for the carriage of goods, trucks and vans. O addresses trailers, including semi-trailers, as long as it is outfitted with at least one ECU. R156 also addresses vehicles of categories R, S, and T. R addresses other vehicles, could be human-powered, animal-powered vehicles like bicycles and carts, wheelchairs, motor vehicles without carriage body, caterpillar vehicles, one-axle tractors, etc. S addresses movable industrial machines. T addresses agriculture and forestry tractors. I don't expect you to read all this, know where I cover each definition. But this is actually the complete list of definitions for both R155 and R156. Not necessarily as comprehensive as you might see in other regulations and standards, though. As I discuss the application for approval, remember I have used a / to differentiate items between R155 and R156. As a result, for example, in the right-hand box, 3.3 is the paragraph for R155 and 3.7 is the paragraph for R156. So the numbering may be slightly different, but the context is the same. Section 3 covers application for approval in terms of who should submit the application, what documents should be submitted and submitted in triplicate and broken out in 2 parts. The application can either be submitted by the OEM or by their duly accredited representative. It shall include the description as per Annex 1 information document and also include the certificate of compliance for the CSMS or SUMS. See Section 6 about that. If the information is shown to be covered by intellectual property rights or to constitute specific know-how of the manufacturer and of their suppliers, the manufacturer or their suppliers shall make available sufficient information to enable the checks referred to in this regulation to be made properly. And such information shall be treated on a confidential basis. Finally, submit the documentation in 2 parts. Part A, package as per Annex 1 is submitted and shall be available for 10 years past vehicle discontinuation. Part B should provide additional material relevant to the requirements of this regulation, but for the same time period. Section 4, markings, displays, and discusses how the approval is represented and placed. The marking shall be clearly legible and shall be indelible, meaning it cannot be easily removed, and be affixed conspicuously and in a readily accessible place specified on the approval form, i.e. placed on or close to the vehicle data plate to every vehicle conforming to a vehicle type approved under the regulations. The marking is an international approval mark consisting of a circle surrounding the letter E with the approving country's ECE R10 symbol, 4 for the Netherlands in this example. Speaking of the approving country, as per UNECE member countries, no matter in which country the approvals are conducted, the provided certificate will be valid across the entire European Union. Next, to the right of the circle, you have regulation number 155 or 156, followed by the letter R-approval number. You only need to include one symbol prescribed in 4.1.1 for complying with multiple regulations. Just include both numbers arranged vertically as depicted here. Finally, note that Annex 3 to this regulation gives examples of the arrangements of the approval mark. Section 5 for the approval is a bit verbose, I suppose, so I'm only going to summarize things here. Of course, type approval shall be granted only to compliant vehicle types, and the approval authority or the technical service shall verify by testing of the vehicle type that the vehicle manufacturer has implemented the measures that they have documented. For R155, also see Annex 5, list of threats and corresponding mitigations. Notice of approval or of extension or refusal of approval of a vehicle type pursuant to this regulation shall be communicated to the parties of the 1958 agreement, which applied this regulation by means of a form conforming to the model of Annex 2 of this regulation. Finally, the approval authority, such as KBA in Germany, symbol E1, must verify to ensure that the OEM follows all procedures. Note, approval authority could also be its technical service. Also, generally the certification is issued by a type approval authority and the tests are carried out by designated technical services. A lot of text here, I know. Well, regarding Section 6, Certificate of Compliance for CSMS or SUMS, consider the following. Approval authorities are appointed to assess the OEM and to issue a certification of compliance for the CSMS and or SUMS. An OEM or their duly accredited representative shall submit an application for their certificate of compliance. The application shall be accompanied by the undermentioned documents in triplicate and by the following in particular. Documents describing the CSMS or SUMS, example, ISO SAE 21434 or ISO 2489 work products, a signed declaration using the model as defined in Appendix 1 to Annex 1. OEMs, as per Appendix 1 to Annex 1, shall declare and demonstrate their processes leading to compliance for their CSMS or SUMS. Successful completion shall lead to the granting of the OEM Certificate of Compliance for their CSMS and or SUMS. The Certificate of Compliance shall remain valid for a maximum of 3 years from the date of deliverance. The approval authority may at any time verify that the requirements for it continue to be met, or withdraw the Certificate of Compliance if the requirements are no longer met. The OEM shall inform the approval authority of any change that will affect the Certificate of Compliance. The approval authority or its technical service shall decide whether new checks are necessary. In due time, the OEM shall apply for a new or for the extension of the existing Certificate of Compliance. The approval authority shall, subject to a positive assessment, issue a new Certificate of Compliance or extend its validity for a further period of 3 years. Finally, for R155 only, the expiration or withdrawal may include the withdrawal of the approval if the conditions for granting the approval are not met anymore. And for R156 only, existing vehicle types approvals shall not lose their validity due to the expiration of the manufacturer's Certificate of Compliance for Software Update Management System. I know these two seem a bit contradictory. For R155, specifications are essentially the requirements to implement and certify your CSMS. Note that Section 7 for specifications are where the items discussed are very specific to R155 or R156. The most specific of any section besides Annex 5, which is specific to R155. Now let's discuss the specifications that are specific to R155. Though right now, I'm only going to mention the high-level descriptions of the sections. Near the end of this presentation, I will expose the nitty-gritty details. And a bit of trivia for you to share when you're out with your friends. R156 calls them general specifications. You're welcome. LOL. As mentioned, aspects of Section 7 are covered in more detail near the end of this presentation, and I will also include a reference to the associated ISO SAE 21434 clauses or requirements with the help of the AVCDL. Well, I'll make a quick mention about the Autonomous Vehicle Cybersecurity Development Lifecycle, or AVCDL. The AVCDL is a process framework, and its purpose is to provide a cybersecurity development lifecycle suitable for the creation of safety-critical cyber-physical systems. Relationships between the standards and regulations covered here are represented in the AVCDL mapping spreadsheet. More on the AVCDL later in the presentation. Section 7, R155 specifications consist of 4 paragraphs, 7.1 through 7.4. 7.1 covers some general specifications. 7.2 covers the overall requirements for the CSMS. 7.3 covers specific requirements for the vehicle types. And 7.4 covers the reporting provisions. I will get into more details for all these later in the presentation. For R156, specifications are essentially the requirements to implement and certify your SUMS. Now let's discuss the specifications that are specific to R156. Although right now, again, I'm only going to mention the high-level descriptions of the sections. As with the specifications that are specific to R155, near the end of this presentation, I will expose the nitty-gritty details of the specifications for R156. As mentioned, aspects of Section 7 are covered in more detail near the end of this presentation, and I will also include a reference to the associated ISO 24089 clauses or requirements with the help of the AVCDL. Section 7 R156 specifications consists of two paragraphs, 7.1 and 7.2. 7.1 covers the overall requirements for the sums, and 7.2 covers specific requirements for vehicle types. And unlike R155 specifications, R156 does not cover reporting provisions. I will get into more details for all these later in the presentation. Now, let's discuss sections 8 through 12. Section 8 covers the modification and extension of vehicle type. As such, every modification of the vehicle type, which affects its technical performance and/or documentation required in this regulation, shall be notified to the approval authority which approved the vehicle type. The approval authority may then either, one, consider that the modifications made still comply with the requirements and documentation of the existing type approval, or two, proceed to necessary complementary assessment pursuant to paragraph 5 and require, where relevant, a further test report from the technical service responsible for conducting the tests. In addition, confirmation or extension or refusal of approval specifying the alterations shall be communicated by means of communication form conforming to the model in Annex 2 of this regulation. Finally, the approval authority issuing the extension for approval shall assign a series numbers for such an extension and inform the other parties to the 1958 agreement. Section 9 covers conformity of production, or COP. Each holder of a type approval must install and use specified testing and inspection procedures to ensure effective conformity of production for manufacturing all vehicles for which the type approval applies. Vehicle and vehicle component manufacturers are obliged to prove their products match the specification, performance, and marking requirements set out to the original type approval documentation. And the holder of the approval shall ensure the results of the conformity of production tests are recorded and that the annex documents remain available for a period determined in the agreement with the approval authority of technical service. This period shall not exceed 10 years, counted from the time when production is definitely discontinued, as discussed in Section 11. In addition, the approval authority, which is granted type approval, may at any time verify the conformity control methods applied to each production facility. The normal frequencies of these verifications shall be once every 3 years. And finally, the approval authority or its technical service shall periodically validate that the processes used and decisions made by the vehicle manufacturer are compliant, particularly, for instance, where the vehicle manufacturer chose not to notify the approval authority or its technical service about an update. Now, regarding nonconformity of production. Well, these three, sections 10, 11, and 12, are the shortest sections, and as such, I've combined them here. Regarding Section 10, penalties for nonconformity of production, the approval granted in respect of a vehicle type pursuant to this regulation may be withdrawn if the requirements laid down in this regulation are not complied with, or if sample vehicles fail to comply with the requirements of this regulation. If an approval authority withdraws an approval it has previously granted, it shall forthwith notify the contracting parties applying this regulation by means of communication form conforming to the model in Annex 2 of this regulation. Regarding Section 11, production definitely discontinued, if the holder of the approval completely ceases to manufacture a type of vehicle approved in compliance with this regulation, he shall so inform the authority which granted the approval. Upon receiving the relevant communication, that the authority shall inform other contracting parties to the agreement applying this regulation by means of a copy of the approval form bearing at the end in large letters the signed and dated annotation "production discontinued" in all uppercase. Regarding Section 12, names and addresses of technical services responsible for conducting approval tests and type approval authorities. The contracting parties to the agreement which apply this regulation shall communicate to the United Nations Secretariat the names and addresses of the technical services responsible for conducting approval tests and of the type approval authorities which grant approval and to which forms certifying approval or extension or refusal or withdrawal of approval issued in other countries are to be sent. Now that I've covered the sections, although I'll still cover the details of Section 7 following, I will now cover Annexes 1 through 4. Annex 5, of course, is only relevant to R155, and I will cover that following. But 1 through 4 are pretty much the same for both. Annex 1 has 9 items. Items 1 through 8 are the same for both R155 and R156, where item 9 is specific to each and will be covered separately. Earlier, as mentioned in Section 3, application for approval, the application can either be submitted by the OEM or by their duly accredited representative. It shall include a description as per Annex 1 information document. That description is represented here. Annex 1, Item 9, information on cybersecurity is relevant to R155, of course. It includes the general construction characteristics of the vehicle type, including the vehicle systems relative to cybersecurity, essentially the electrical and electronic or E/E systems, their components and their interactions. It should include a schematic representation of the vehicle type and the number of the certificate of compliance for the CSMS as per Section 6. And the documentation describing the outcome of its risk assessment and identified risks and how they address the stated risks, i.e. the mitigations. Also, documentation describing protection of dedicated environments for aftermarket software, services, applications or data, documents describing what tests have been used to verify the cybersecurity of the vehicle type and its systems and the outcome of those tests. And finally, a description of the consideration of the supply chain with respect to cybersecurity, i.e. how the supply chain is managed. Annex 1, Item 9, information on software updates is relative to R156, of course. It includes general construction characteristics of the vehicle type and the number of the certificate of compliance for the sums as per Section 6. Additionally, documentation for the security measures taken describing the update process will be performed securely and describing that the Management of Software Identification Scheme, or RxS-WIN, on the vehicle is protected against unauthorized manipulation. Finally, documentation for software updates over the air describing that the update process will be performed safely and how a vehicle user is able to be informed about the update before and after its execution. Annex 1, Appendix 1, applies equally to both R155 and R156. It is the model of manufacturer's declaration of compliance for CSMS or SUMS, which is the manufacturer's declaration of compliance with requirements for the Cybersecurity Management System and Software Update Management Systems, respectively. So really, it's just an acknowledgement and an assumption of responsibility. Annex 2, communication, also applies equally to both R155 and R156. To a certain extent, this was covered in Section 4 for markings and Section 5 for approval. The communication indicates whether the approval was granted, extended, refused, or withdrawn. Accordingly, strike out what does not apply. If applicable, the approval or extension number should also be recorded. Annex 2 communication also includes this additional information, such as the reason for the extension, if applicable, and additional information regarding the vehicle type, location of the marking, applicable names and addresses of the OEM's representative, the number of the certificate of compliance as per Section 6, and information regarding the testing activities as mentioned in Section 5. Well, you got me why both Section 4 markings and Annex 3 essentially cover the same thing. So I'm intentionally not going to cover it in more detail again. Well, because life is too short, right? Annex 4 displays the model of certificate of compliance for CSMS or SUMS as discussed in Section 6. Essentially, as per Section 6, approval authorities assess and issue a certificate of compliance. Then OEMs submit an application for their certificate of compliance. Once issued, this information is available and recorded and displayed here. Annex 5 is only relevant to R155, and I will cover that now. But remember to keep watching because I will cover the details of Section 7 for R155 and R156 following this. Yes, I know this is a long presentation. Perhaps take a coffee break since we're about halfway through. Annex 5 contains a list of threats and corresponding mitigations. During the type approval process, vehicle tests are performed to check whether mitigations are implemented against common threats. These are a baseline test suite for type approval authorities to use as part of the type approval testing process. Annex 5 consists of 3 parts. Part A describes the baseline for threats, vulnerabilities, and attack methods. Part B describes mitigations to the threats, which are intended for vehicle types. Part C describes mitigations to the threats, which are intended for areas outside the vehicle, for example, on IT backends and even on OT. As you will see, the tables in parts B and C include a linkage to each of the attack vulnerability with a list of corresponding mitigation measures. What could go wrong, right? It's important to determine the impact of attack, as well as the likelihood of the attack occurring, which will lead to a risk profile. This is accomplished as per ISO SAE 21434 clauses 9 and 15 for threat analysis and risk assessment, or TAR. The greater the risk and the greater the anticipated damage, the more rigor should be exercised to protect against the risk. Part A, vulnerability or attack method related to threats, has table A1, which is a list of threats and relating vulnerability or attack method. These are broken out and grouped in subsections 4.3.1 through 4.3.7, depending on the attack surface being considered. Whether it's attacks on the backend servers, as in 4.3.1, or on the vehicle components in 4.3.2 through 4.3.7. There are 32 vulnerabilities. Well, minus 2 since vulnerabilities 14 and 30 not listed in R155 for some reason, or attack methods related to the threats. For example, 4.3.1 has 3 sublevels, 1 through 3, and 4.3.7 has 7 sublevels, 26 through 32, or I suppose 6 since number 30 is not listed in R155. As mentioned previously, subsection 4.3.1, threats regarding backend servers related to vehicles in the field, has 3 sub-level descriptions of vulnerabilities, 1 through 3, and each of those has examples of vulnerability or attack methods. For example, sub-level 1, backend servers used as a mean to attack a vehicle or extract data, has 3 examples, 1.1 through 1.3. Where 1.1 addresses abuse of privileges by staff, an insider attack. Following, you will see how mitigation 1, or M1, is tied to 4.3.1, example 1.1, when we discuss part C, mitigations to the threats outside of vehicles. Specifically in table C.1, mitigations to threats which are related to backend servers. As mentioned previously, there are 32 vulnerabilities represented as R155 IDs here, grouped by high-level subsections 4.3.1 through 4.3.7 as depicted here. This table was taken from the AVCDL UNECE WP.29 R155 spreadsheet, where it is also identified the systems involved in the attack. The system can be the product, which are vehicles addressed by Part B mitigations to the threats intended for vehicles, and or IT for information technology or OT for operational technology, for which IT and OT are addressed by Part C mitigations to threats outside the vehicles. As mentioned previously, the system can be the product, which are vehicles addressed by Part B mitigations to threats to vehicles discussed here. In total, R155 is 24 mitigations, mitigation 1 through 24, well, minus 1 since mitigation 17, M17, is not listed in R155 for some reason. And some support multiple vulnerabilities and threat. For example, M10 supports 5, but only 4.1 is shown here. Each mitigation is listed in a corresponding table, such as Table B1, mitigations to threats which are related to vehicle communication channels, and that's depicted here. Following, I will list all 8 Part B tables. Each Part B table has a Table A1 reference and description, 4.1 and spoofing of messages by impersonation respectively here, as well as a mitigation reference and description. M10, and the vehicle shall verify the authenticity and integrity of messages it receives, respectively here. Note that Table A.1 references come from a high-level number, 4.3.2 here, sub-level number 4 here, and ultimately the associated example number, which is 4.1 here. Part B mitigations to the threats intended to vehicles includes 8 tables, which are listed here. Each table can have 1 or more mitigations and their associated Table A1 reference. I am not going to read them all off now, but these mitigations are the threats which are related to vehicle communication channels. In Table B1, or mitigations to threats which are related to physical manipulation of systems to enable an attack in Table B8, for example. Each mitigation can be represented multiple times in a table and can even be represented in multiple tables. The previous slide mentioned M10 from Table B1. I already mentioned that M10 addresses Part A vulnerabilities, reference 4.1 in Table B1. Notably, M10 also addresses 5 vulnerabilities, 4.1, 5.1, 6.1, 6.2, and 11.2, also listed in Table B1. Whereas M7 addresses vulnerabilities in Table B1 and B5. Finally, M24 is interesting because it addresses vulnerabilities in tables B7 and C3. As mentioned previously, M24 is interesting since it addresses vulnerabilities in tables B7 and C3. I will discuss Part C mitigations next. As mentioned previously, the system can be IT for information technology or OT for operational technology, for which IT and OT are addressed by Part C, mitigations to the threat outside of vehicles. Really, the format of Part B and C are the same. Table reference and description, and mitigation reference and description. I already discussed this format and such in detail relative to Part B, so I will not rehash that now. Part C, mitigations to the threats outside of the vehicle, includes 3 tables that are depicted here. Since the lists are small, I have included all of them here. Contrast that with the 8 tables listed in Part B. Basically, the how and why relative to having multiple tables, as well as how each addresses multiple mitigations, was addressed in Part B, so I will not rehash that now. There are many more ways to attack vehicles directly than there are threats outside of vehicles, hence the scaled back list for Part C. Table C1 has 6 mitigations listed, M1 through M5 and M8. Table C2 has 2 mitigations listed, M18 and M19. And Table C3 has only a single mitigation listed, M24. As mentioned previously, there are 24 mitigations represented as R155 ID here. This table was also taken from the AVCDL UNECE WP.29 R155 spreadsheet, where it also identified the system or systems involved in the attack. Similar to how each but not all mitigations can be represented multiple times in a table and even represented in multiple tables. As you can see here, each mitigation can address multiple Table A1 vulnerability or attack methods related to the threats references. Now let's discuss the AVCDL. As I mentioned previously, the Autonomous Vehicle Cybersecurity Development Lifecycle, or AVCDL, is a process framework, and its purpose is to provide a cybersecurity development lifecycle suitable for the creation of safety-critical or cyber-physical system. I have included the URL for the AVCDL GitHub repository here. The repository contains material related to the AVCDL and is available for free. Block Harbor's VSEC platform includes modules or blocks to both solve a specific pain point in the journey to cyber-safe systems in automotive and to allow interoperability with other blocks. Overall, VSEC is a hub where all product security-related activities can be performed and tracked to create a complete vehicle security engineering suite. One of those blocks is called Breakwater, is a set of automated vehicle tests that checks whether mitigations are implemented against common threats. This is aimed to cover UN R155 threats and mitigations, just covered as Annex 5 to R155, and to provide a baseline test suite for type approval authorities to use as part of type approval testing processes. Specifications are essentially the requirements to implement and certify your CSMS. Note that Section 7 for specifications are where the items discussed are specific to R155 and R156. The most specific of any section besides Annex 5 just covered, which is specific to R155. I previously introduced you to the high-level overview of Section 7 for R155. Now let's discuss the nitty-gritty details. Section 7 R155 specifications consist of 4 paragraphs, 7.1 through 7.4. 7.1 covers some general specifications, 7.2 covers overall requirements for CSMS, 7.3 covers specific requirements for vehicle types, and 7.4 covers the reporting provisions. Besides 7.1, which is basically all that it is listed here, each paragraph is covered in more detail next. And I will also include a reference to the associated ISO SAE 21434 clauses and requirements. Speaking of referencing the associated ISO SAE 214 normative clauses or requirements, this table was reproduced from the ISO SAE 21434 standard. The clauses are 5, organizational cybersecurity management, 6, project-dependent cybersecurity management, 7, distributed cybersecurity activities, 8, continual cybersecurity activities, 9, concept, 10, product development, 11, cybersecurity validation, 12, production, 13, operations and maintenance, 14, end of cybersecurity support and decommissioning, and 15, threat analysis and risk assessment methods. Just remember, I did record a fresh look at ISO SAE 21434 presentation, which you could also find on my LinkedIn page. Paragraph 7.2 covers CSMS requirements, 7.2.1 and 7.2.2. 7.2.1 just states that for the assessment, the approval authority or its technical service shall verify that the vehicle manufacturer has a cybersecurity management system in place and shall verify its compliance with the regulation. This is essentially related to all ISO SAE 21434 clauses. 7.2.2 states that the CSMS shall cover aspects covered in paragraph 7.2.2.1 through 7.2.2.5. Here I'm addressing 7.2.2.1, which requires an OEM to demonstrate that their CSMS applies to the following phases: development, production, and post-production phases, of which are addressed by the work products and ISO SAE 21434, clauses 8 and 10 through 14. Similar to ISO SAE 21434 Clause 5, R155, Section 7.2.2.2 requires organizational processes to manage cybersecurity. This includes governance, competency, culture, sharing of information between departments in the supply chain, as well as training. This also includes processes used for the identification of risks, the assessment, categorization, management, and treatment of risks, and especially keeping these processes current. In addition, processes used for testing the cybersecurity of vehicle type as per Annex 5, and the ongoing and effectiveness of processes used to detect, monitor, and support the analysis and of responding to cybersecurity attacks. As such, the requirements for addressing these are covered by multiple ISO SAE 21434 clauses, including clauses 7 through 13, and especially clause 15. While it seems like paragraph 7.2.2.3 and through 7.2.2.5 are similar or even redundant relative to 7.2.2.2, there are some slight differences. The OEM shall demonstrate that the processes used within their CSMS support not just mitigating the risk, but they are mitigated within a reasonable time frame, that monitoring be continual, and that the OEM shall demonstrate how their CSMS will manage supplier dependencies. Again, a number of ISO SAE 21434 clauses come into play, including clauses 6, 7, 8, 11, and 13. Whereas section 7.1 and 7.2 discusses requirements for the overall CSMS, 7.3 addresses requirements specifically at the vehicle level. Section 7.3 includes paragraphs 7.3.1 through 7.3.8. Here I will cover 7.3.1 through 7.3.3, and then 7.3.4 through 7.3.8 following. Again, some of these were addressed in the overall requirements within paragraph 7.1 and 7.2 for CSMS, but now we're focusing on the vehicle level or type. Now, 7.3.1 states that not only should the OEM have a valid certificate of compliance for their CSMS, but it to be relevant to the vehicle type being approved. For this, all ISO SAE 21434 clauses could apply. Also, it is notable that an OEM could have multiple instances of approved CSMS, each per vehicle type, since most OEMs do offer multiple vehicle types. Section 7.3.2 and 7.3.3, again, are very similar to section 7.2.2.2 regarding identifying and managing supplier-related risks, as well as perform an exhaustive risk assessment and treatment. But again, addressing these at the vehicle level. The items discussed in these two sections are honed in by ISO SAE 21434, clauses 7, 9, 10, 12, and 15. Note that 7.3.4 was represented by a single paragraph on R155. However, I have broken those out into an A through F here for more clarity. As such, the OEM shall protect the vehicle type against identified risks by implementing the mitigations referred to in Annex 5, Parts B and C, and by July 1st, 2024 for all production vehicles, not just new vehicles, but also ensure other appropriate mitigations. However, for vehicle type approvals prior to July 1st, 2024, the vehicle manufacturer shall ensure that another appropriate mitigation is implemented if a mitigation measure referred to in Annex 5, Part B and C is technically not feasible. The respective assessment of the technical feasibility shall be provided by the manufacturer to the appropriate authority. In terms of ISO SAE 21434 requirements, these are from clauses 9 and 15. I will wrap up coverage of paragraph 7.3 by covering 7.3.5 through 7.3.8. While there are also some similarities with Section 7.2, some of the differences are that as per 7.3.5, the OEM shall protect the storage and execution of aftermarket software, services, applications, or data. That is storage and execution on the vehicle. 7.3.6 and 7.3.7 discuss the requirements to perform appropriate and sufficient testing to verify security measures and implement measures relative to the detection and prevention of cyber attacks against vehicles, supporting threat monitoring capabilities and providing data forensic capabilities to enable analysis of attempted or successful attacks, again, for the vehicle type. Finally, 7.3.8 requires that cryptographic modules shall be in line with consensus standards, otherwise justify why not. As you can see, the relevant ISO SAE 21434 clauses and requirements are listed here. I will wrap up discussing Clause 7 relative to R155 by covering paragraph 7.4 reporting provisions. First, there is 7.4.1, mentioning that an OEM shall report at least once a year the outcome and effectiveness of their monitoring activities and mitigations implemented for their vehicle types. So the associated ISO SAE 21434 requirements are from Clause 8. Lastly, there is 7.4.2 stating that the approval authority shall verify the provided information and require the OEM to remedy any detected ineffectiveness, otherwise to withdraw the CSMS certificate of compliance as per section 6.8. Notably, 7.4.2 is not covered by ISO SAE 21434 requirements. Specifications are essentially the requirements to implement and certify your SUMs. Note that Section 7 for specifications are where items discussed are specific to R155 and R156. The most specific of any section besides Annex 5 previously covered, which is specific to R155. Also, I previously introduced you to the high-level overview of Section 7 for R156. Now let's discuss the nitty-gritty details. Section 7 specifications for R156 consist of two paragraphs, 7.1 and 7.2. Section 7.1 covers the overall requirements for the SUMs, and 7.2 covers specific requirements for vehicle types. And unlike R155 specifications, R156 does not cover reporting provisions. As with Section 7 for R155, I will also include a reference to the associated ISO 24089 clauses or requirements with the help of the AVCDL. Notably, ISO 24089 does not include the RQ prefix for requirements. Speaking of referencing the associated ISO 24089 normative clauses and requirements, this table was reproduced from the ISO 24089 standard. The clauses are 4, organizational level, 5, project level, 6, infrastructure level, 7, vehicle and vehicle systems level, 8, software update package, and 9, software update campaign. Just a reminder, I did record a fresh look at ISO 24089 presentation, which you can also find on my LinkedIn page. Section 7.1 requirements for SUMs includes paragraph 7.1.1, processes to be verified, which includes 7.1.1.1 to 7.1.1.12. Here I will cover 7.1.1.1 through 7.1.1.6. 7.1.1.1 is similar to ISO 24089 Clause 4 and requires relevant information is documented and securely held and can be made available. 7.1.1.2 through 7.1.1.4 are regarding the handling of software versions, data integrity, and relevant hardware components that can be uniquely identified. This includes managing designated RxS win for each update as discussed previously, which, by the way, is not covered by ISO 24089 requirements. Finally, identifying interdependencies of the updated system with other systems and identifying target vehicles for a software update. These are covered by ISO 24089 clauses 6, 8, and 9. Here I will cover 7.1.1.7 through 7.1.1.12. Now, processes must confirm the compatibility of software update with the target vehicle's configuration. So the associated ISO 24089 requirement is from Clause 8. Identify and record whether software update will affect any type approved systems. Identify and record whether a software update will add, alter, or enable any functions that were not present or enabled, neither of which are covered by ISO 24089 requirements. The ability to identify and record if a software update will affect any other system required for the safe and continued operation of the vehicle, or if the update will add or alter functionality of the vehicle related to ISO 24089 Clause 9. And finally, a process whereby the vehicle user is able to be informed about the updates, which is related to ISO 24089 Clauses 6 and 9. Section 7.1 requirements for the sums also includes paragraph 7.1.2, states that the vehicle manufacturer shall record and store update information. 7.1.2.1 through 7.1.2.5. Here I'll cover 7.1.2.1 to 7.1.2.4. This includes the documentation describing software update processes and the configuration of any relevant type approved systems before and after an update. Related to ISO 24089 Clause 4 and Clauses 6 and 9 respectively. Again, keeping track of and registering the RxWin is not covered by ISO 24089 requirements. And finally, documentation listing target vehicles for the update and confirmation of the compatibility of the last known configuration of those vehicles with the update is covered by ISO 24089 Clause 8. Here I will cover 7.1.2.5. 7.2.1.5 requires that documentation for all software updates for the vehicle type include the purpose of the update, affected systems and functions, and how the update may or may not affect the existing type approval or fulfillment of any of the relevant requirements. In addition, how the update may be executed and under what conditions, how the software update will be conducted safely and securely, and confirmation that the software update has undergone and successfully passed verification and validation procedures. ISO 24089 Clause 8 and 9 mainly cover these, I suppose, with the exception of C to F. Section 7.1 requirements for the sums also includes paragraph 7.1.3 security. As such, an OEM shall demonstrate that the process they will use to ensure that software updates will be protected and reasonably prevent manipulation before the update process is initiated, are protected to reasonably prevent them from being compromised, including development of the update delivery system, and the processes used to verify and validate software functionality and code for the software used in the vehicle are appropriate. Except for the latter, ISO 24089 Clauses 4, 5, 6, and 8 covers these. Finally, it also includes paragraph 7.1.4, additional requirements for software updates over the air or OTA. As such, an OEM shall demonstrate the processes and procedures they will use to assess that over-the-air updates will not impact safety if conducted during driving. So the associated ISO 24089 requirement is from Clause 4. Also, the OEM shall demonstrate the processes and procedures they will use to ensure that when an over-the-air update requires a specific skill or complex action, for example, recalibrate a sensor post-programming in order to complete the update process, the update can only proceed when a person skilled to do that action is present and is in control of the process. This information is covered by ISO 24089 requirements from Clause 9. Continuing on, whereas Section 7.1 covered requirements for the sums, Section 7.2 covers requirements for the vehicle type and includes paragraph 7.2.1 requirements for software updates and 7.2.2 additional requirements for over-the-air updates. Here I'll cover 7.2.1, which includes 7.2.1.1, stating that the authenticity and integrity of software updates shall be protected to prevent invalid updates. This is addressed by ISO 2489 Clause 7. And as per 7.2.1.2, some requirements for the vehicle type uses RxS WIN, which are not covered by ISO 2489 requirements. Previously, I covered 7.2.1 requirements for software updates. Now I will cover section 7.2.2, additional requirements for over-the-air updates. 7.2.2 includes 7.2.2.1 through 7.2.2.5. Here I'll cover 7.2.2.1. 7.2.2.1 has 3 paragraphs stating that the vehicle shall have the following functionality with regards to software updates. The OEM shall ensure that the vehicle is able to restore systems to their previous version in case of a failed or interrupted update, or that the vehicle can be placed into a safe state after a failed or interrupted update. Shall ensure that the software updates can only be executed when the vehicle has enough power to complete the update process, including that needed for a possible recovery to the previous version or for the vehicle to be placed into a safe state. And that when the execution of an update may affect the safety of the vehicle manufacturer shall demonstrate how the update will be executed safely. And for all of these, the associated ISO 24089 requirements are from Clause 7. Finally, and yes, this is the final coverage of R156, Section 7. Previously, I covered 7.2.2.1. Here I'll cover 7.2.2.2 through 7.2.2.5. As such, the OEM shall demonstrate that the vehicle user is able to be informed about an update, plus accompanying information. Also, if the execution of an update while driving may not be safe, either make sure it cannot be driven during the update, or make sure that the driver is not able to use any of the functionality of the vehicle that would affect the safety. After the execution of an update, the OEM shall demonstrate how the vehicle user is able to be informed of the success or failure of the update, and how the vehicle user is able to be informed about the changes implemented. Finally, the vehicle shall ensure that preconditions have to be met before the software update is executed. These are also covered by ISO 24089 Clause 7. Okay, I would like to close now by mentioning how SAC can help secure your future in automotive cybersecurity. Connect with our experts to streamline your compliance journey, fortify your cybersecurity defenses, and stay ahead in the evolving automotive landscape. Your security is our priority. Reach out now for a consultation tailored to your needs. So there you have it. I hope that you enjoyed this presentation I put together on automotive cybersecurity and the UNECE WP.29 regulations 155 and 156. Please reach out to me at SAC to discuss how we can help your organization to ensure that your products are secure by design. Thank you for your time.